So in this video, we're going to be investigating sort of the patterns of the unit circle. How can somebody remember or apply the knowledge of the unit circle? You have to look deeply at the patterns of the coordinates. So at the bottom here, we have these 5 magical numbers. And I've written these 5 magical numbers in ascending order. The smallest of these 5 numbers, 0, 1/2, 1 over root 2, root 3 over 2, comma 1. Knowing these numbers in this order will help us understand how these numbers work. So just take a look at the coordinates, the xy coordinates as we move around this circle. And obviously you're likely wondering that there is a pattern. However, you may be finding it difficult to understanding. So I'm going to, for instance, look at the sine ratio, and I'm just going to use this bar here. Looking at the smallest of the numbers is 1/2. So I'm going to start off where sine theta is equal to 0. And what we see is sine theta is equal to 0 exactly at 0 and 180. In other words, in this position and this position. As we move this line upwards, upwards is this way, the next highest y value, or sine value, is 1/2. So this is the point where sine theta is equal to 1/2, 30 and 150. If we continue moving this up, the next number is 1 over root 2. So the 45-degree family has a y value of 1 over root 2. And as we continue up, root 3 over 2, these are the two positions, root 3 over 2, because they're very high up on the unit circle, not the highest would be 1, but the sine value here is root 3 over 2. So then as we go all the way up, here's where sine is equal to 1. So sine is equal to 0, sine is equal to 1/2, sine is equal to 1 over root 2, sine is equal to root 3 over 2, and sine is equal to 1. So we could also make the same argument for the negatives. Sine is equal to 0. The y value is equal to -1/2, so sine is equal to -1/2. Sine is equal to negative 1 over root 2. Sine is equal to negative root 3 over 2. And sine is equal to -1 at the bottom of the unit circle. Now I'm going to be taking a look at cosine. Now, cosine is a measurement of the x, and I always find it 0 as my home base whenever I'm looking for sine or cosine. So remember that x is equal to a constant is an equation of a vertical line. So since my vertical line here that I'm talking about, I'm be moving back and forth, this is where x is equal to 0. In other words, these are the two angles where cosine is equal to 0. As we move more to the left, our cosine or our x coordinates gets larger. So 0, the next notch up that's larger is 1/2. So that's where cosine is equal to 1/2, 60 and 300. Cosine is equal to, cosine theta is equal to 1 over root 2 at 45 and 330. Cosine is equal to root 3 over 2 at 30 and 330. So really, root 3 over 2 I know is very close to 1. So it's going to be very far over to the right since I'm talking about horizontal, right? X is horizontal. Now, cosine is equal to 1 at 0 degrees, also 360, or any angle that terminates in this position. Same argument can be made if we go into the negatives. So this is where cosine is equal to 0. These two angles here, 240 and 120, is where cosine is equal to -1/2, negative 1 over root 2, negative root 3 over 2. So cosine is equal to negative root 3 over 2. So the x-coordinates are negative root 3 over 2. It's 150 and 210. And there we are. Cosine is equal to negative 1 over here. So I know last year, I'm just going to put over here, if you want, you can put this into your calculator. What angle has a cosine value of negative 1.2? No angle. If you try to figure this out in your calculator, the inverse cos of anything that is not between negative 1 and 1 will give you an error because there's no such angle that exists. So last but not least, I'm going to be looking at the tangent ratio. Now the tangent ratio is kind of a curious thing, isn't it? And really the tangent ratio is the slope, a measurement of the slope, because it is sine divided by cosine. So I'm just going to start off. So this is where my slope is 0. These two angles, what's the slope of this line here? It's 0. So these two angles have a slope of 0, so therefore they have a tangent of 0. Now, I'm hoping that if you look at your unit circle table of values that you constructed, you're able to say, wait a second, 30 and 210 have a tangent of 1 over root 3. And as you go steeper yet, we have a slope of 1. We have a slope of root 3. Now, tangent's a little bit more difficult because you almost have to calculate it or memorize those extra values, but it's really slope. So tangent's equal to 0 at 0 and 180. Tangent's equal to, 1 over root 3 at 30-degree family. Tangent's equal to 1 in the 45-degree family. Tangent's equal to root 3 at 60 and 240. Same argument can be made. Now, where is tangent negative? It's when these terminal arms, the slope is negative. So that's a low slope, negative 1 over root 3. So tangent's equal to negative 1 over root 3 at 150 and 330. Tangent's equal to negative 1 at these two angles. Tangent's equal to negative root 3 at 120 and 300. So the ones that I haven't talked about is, what is the tangent of 90 degrees? So I'm unable to draw a line that is going directly, my terminal arm going from the origin to 90 degrees. But if I ask you, what is the slope of a vertical line? It should be undefined. So the tangent of 90 degrees is undefined. If you want, try that out in your calculator. Tangent 90 degrees equals, you should have an error. Similarly, the tangent of 210, the terminal arm will go up and down vertically. What is the slope of a vertical line? It is undefined. I hope this helps. I hope this helps you conceptualize and organize your thoughts. If you have any questions, feel free to ask. We're going to be applying this knowledge and our knowledge of waves in future lessons.